Hi, today we're looking at Star Battle. Fairly simple little spatial awareness puzzle, although they can get pretty big and pretty complex. I'm going to start with a 2-star puzzle. First of all, I'll explain the rules. The grid is very simple looking. As you can see, there are no numbers to deal with. And the objective of the puzzle is to place a star into each region, so the regions are the bold areas like this, and also into each row and column. The only other rule is that stars cannot touch either horizontally, vertically or diagonally. So if you had a star in here, for example, you could not have a star in any of the cells around it. Now in this version of the puzzle, we're only looking to place one star into each region, row and column. There are versions where it's necessary to place multiple stars, but this is an easy 2-star puzzle and we're just looking at placing one star in each. So let's have a look at how we get started. And the first thing we can do is look for very simple regions like this 2-cell region up here. This gives us a massive helping hand because we know that one of these 2 cells has to contain a star. And because we can only have one star on each row, the rest of this row cannot contain a star. So what we do is we'll eliminate all of that straight away. And that's the name of the game with Star Battle, is elimination. Rather than looking for where we can place stars, it's easier to look for where we definitely cannot place them. Or you can continue working down the puzzle. This region here, where we've eliminated the top part of it, which means somewhere in this bottom part of this region, we have to have a star. So that means that we can eliminate this cell here because we can't have 2 on the same row. So that's gone. And that has a further consequence in that this region here is also now split into 2. We can't have a star up here. So one of these 2 cells must contain a star, which means none of these can contain a star because that would be 2 on the same row. And that in itself has another further knock-on effect in that this region here looks a bit like a Tetris piece, doesn't it? One of these 2 cells is now going to have to contain a star, which means we can eliminate all the other cells on that row. They cannot contain stars. That's it as far as the easy ones go, but we've got some further information that we can derive from this 2-cell region up here. And that, in fact, there's a couple of bits of information we can derive from that. First of all, if we have the star in here, then we know we cannot have one here or here because these are adjacent cells. And similarly, if we have one in here, we cannot go there or there because they're adjacent cells. In other words, whatever happens, we can knock out these 2 cells here. So we take those out now. And the other thing we could derive from this 2-cell region at the top is that if we have a star in here, then we're going to have a star in here because this region here, we've only got 3 cells remaining. So either we put in a star in one of these 2 or this one. As I say, if we have a star in here, then we're going to have one here. And if we have a star in here, then we're going to have one in here or here. Either way, we can eliminate this cell here and this cell here because we know that we're going to have stars in that column already. So we'll take those out as well. And lo and behold, having taken this one out, this region now only has 1 cell remaining into which we can put our star, and that's this cell here. And we draw that in yellow. And of course that has a knock-on effect because we cannot have stars in adjacent cells. So none of the cells surrounding that star can contain another star, while these are already taken out, aren't they? But we can also eliminate this one, this one, this one, and this one. So let's cross those out now. And now it's all starting to fall into place, isn't it? Because we've now got a region up here that only has 1 free cell. So that's obviously going to contain a star. And more at it, I should mention that this star, of course, means that we cannot have the star anywhere else in this column. So we can eliminate that and that. And the same thing goes, this star means we cannot have anything in the row. Well, we've already eliminated the row, but we cannot have anything else in the column. So we can take these 2 out as well. If we look at adjacent cells for this star, we can eliminate this one. And that now means that this region only contains 1 free cell for a star. The knock-on effect of that is that we can eliminate all the surrounding cells, including this one, which means we now know we can put our star in there and eliminate the rest of that column because that column now contains a star. So that goes and that goes, which means we have a star in here, which means we then eliminate this one because that is a neighbouring cell. and that leaves just the last cell on the board down here to contain a star, which means that each region now contains a star. Each row contains a star, and each column contains a star, and each star is effectively an island. There are no two stars touching adjacently. So that's it. We've solved that puzzle. Obviously, that's a pretty simple one. Again, this is just a 2-star puzzle. They get much bigger, much more complex, and you won't necessarily have a nice, easy start like this 2-cell Reaching Davis on this puzzle. If you want to try some of these yourself, there's a link in the description to download our free PZF Taster. You can print that out or solve it on a device like I'm doing here. And we put these in the Puzzle Weekly magazine from time to time as well. And of course, that's free as well.
Hello, I'm Auntie. Don't forget you can get our Puzzle Weekly magazine delivered to you every Monday, completely free. Visit the link to get your copy.